Today's section is about factoring special products. So we actually have two special types of factoring patterns that we have. The first one I have listed here is called the difference of squares. So it's what's going to happen when you have a perfect square minus another perfect square. And I have those written out as a squared minus b squared. If you were to factor it, you would end up getting a plus b times a minus b. So in the example I have below, I have 9x squared minus 4. 9x squared, remember, is the same thing as 3x times 3x. 9x squared is a perfect square. 4 is a perfect square. It's the same thing as 2 times 2. So the way that I'm going to write my answer out is as 3x plus 2 times 3x minus 2. So I'll give you a few examples, and whenever I give you these examples, they're usually going to have the directions to factor. Sometimes I'll have it set equal to 0, which I'll make you solve, but just make sure you're aware of which of the two that you're doing. So for my first one, I'm going to do a squared minus 64. So a is the same thing. A squared is the same thing as a times a. 64 is the same thing as 8 times 8. They're both perfect squares, so we write this as a plus 8 times a minus 8. So I'm going to give you two more. The first one is a little easier. It's x squared minus 81. The second one's a little harder. It is 36m squared minus 25. Go ahead and try them both. You can pause if you want to. So for the first one, x squared is the same thing as x times x. 81 is the same thing as 9 times 9. You end up getting x plus 9 times x minus 9. By the way, for any of these problems, if you want to check your answer, you would FOIL it. So if you want to do that, you can. You will find that if you check this one, x plus 9 times x minus 9, you will end up getting x squared minus 9x plus 9x minus 81, and actually your 9x's are going to cancel out, so you do get what you started with. So we're good on that one. That's just a side note. I do recommend that you do that when you're doing a test or quiz, however. So 3 is a harder one. 36m squared is the same thing as 6m times 6m. That actually is a perfect square. 25 is the same as 5 times 5. Our answer is going to be 6m minus 5 times 6m plus 5. Notice how I wrote this one in the opposite order from the previous ones. I put the minus first here. That's completely fine. You are allowed to do that. It's the commutative property, so you're allowed to do that. So this next type of problem is actually a special case. So I would like you to see if you can think of anything that works that will factor. So if you thought about it, you will find that the first thing people want to do is they want to do m plus 8 times m plus 8. However, when you FOIL that, you will end up getting m squared plus 16m plus 64. That one does not work. So that would be your first inclination to do that, but unfortunately it doesn't work. So actually there's nothing that you can do to get this one to work. When that happens, we say it cannot be factored. So there's one more type of problem I want to give you before we move on to the second case that we could have. So this type, I have 2x squared minus 200. You might notice by looking at this problem that 2 and 200 are not perfect squares. However, the other thing that I'm hoping that you might have noticed is that this one has a GCF that we can factor out. So our GCF is 2. So you're going to factor out your greatest common factor, which is 2. So you're going to take the 2, bring it out front. Inside of your parentheses, 2x divided by x, 2x squared divided by x squared is just x squared. 200 divided by 2 is 100, and we have a minus there. Suddenly, this problem has turned into a difference of squares. So we have x squared minus 100. We're going to get x times x, 10 times 10, make one of them positive, make one of them negative, and this is my answer. So here's another one I would like to try. I have negative 4c squared plus 36. So this is a very interesting type of problem because you have that negative there. In my opinion, having a negative with your highest term, which in this case is my x or my c squared term, is not a good thing. So it's always a good idea to factor out any negative. The other thing that you might notice is that 4 and 36 have a common factor of 4. So you're actually going to factor out your GCF of negative 4. So what makes this weird is that negative. So our first term, negative 4c squared divided by negative 4, is just going to give us c squared. Our second term, however, you have to think about it as 36 divided by negative 4. That gives us negative 9. Suddenly we now have another difference of squares. So we're going to get negative 4 times c plus 3 times c minus 3. There's supposed to be a 3. So that's my answer for that problem. Our second special case is called a perfect square trinomial. So this one's a little bit weird. It's a lot harder to spot than the previous one. So if we have a squared plus 2ab plus b squared, you are going to get a plus b squared. Same thing, if you have a minus, it will also work out that way. So if you had a squared, I didn't write that down, but you can add it in, plus 2ab plus b squared is going to give you a minus b. So our example of our first one, you'll notice that 25x squared is a perfect square because it's 5x times 5x. 1 is a perfect square because it's 1 times 1. You will notice that if you do 2 times 5x times 1, you're going to get that middle term. So what's going to happen is this is going to factor as 5x plus 1 squared. Which, by the way, just a side note, this is the same thing as 5x plus 1 times 5x plus 1. Feel free to use the FOIL method to check your answer. So the second one is similar. I'll give you another example below it. So let's say we have 144y squared minus 120 times y plus 25. So for this one, 144y squared is the same thing as 12y times 12y. 25 is the same thing as 5 times 5. And if you take 12y times 5 and then you multiply that one times 2, you will end up getting 2 times 5 is 10, 10 times 12y is 120y, so you will end up getting that special case. And you'll find out that your answer is going to be 12y minus 5 squared. So as I said, this is a harder to recognize one. What I would recommend you do is always, whenever you see something like this, rather than immediately trying the slip and slide method, which is kind of long sometimes, look and see if there's a perfect square with your squared term, and if there's a perfect square for your constant term. If that happens, oftentimes you will get this case. So I'm going to give you one more example, and I believe this is number 7. So we have 4x squared minus 20x plus 25. Go ahead and pause if you want, try that on your own. So you will find that 4x squared is the same thing as 2x times 2x. 25 is the same thing as 5 times 5. Actually, if you do 2 times 2x times 5, you will end up getting 20x. So that one works out. Your answer for that one is 2x minus 5, and it's all going to be squared.